let's talk about valency, oxidation states, and balancing of chemical equation in details. Valency is the combining power of an element, and some we are confused, like how could we know the valency of an exact element and some oxidation states. So here we go about it. For example, let's talk about oxygen. This is the atomic structure of oxygen. So octet stability is the ability of electron to have 8 electrons in this atomic shell. So oxygen requires more 2 electrons to become stable, that is to achieve octet stability. Then it needs to borrow more 2 electrons in order to achieve octet stability. Therefore, the valency of oxygen here is 2. Let's look for another example. Let's look at nitrogen. It will require 3 electrons to complete octet stability. Therefore, its valency is 3. Let's look at oxidation states of some elements in some compounds. Oxidation state of an element which is not undergoing a chemical reaction is perfectly 0. That is, a single element without charge is 0. Then, for ions that have charges, the oxidation states are equal to the number of charges they have. And also, oxidation state of a neutral compound is 0. Let's take for example calcium carbonate. Find the oxidation state of carbon in this compound. The valency of carbon is 4. I've showed you guys how to find valency. Let's find the valency. Carbon here requires 4 electrons in order to complete its stability. So, or it will have to lose these 4 electrons to achieve duplet stability. But carbon will lose the 4 electrons to achieve duplet stability. Therefore, the valency of carbon is 4. I would like us to note another thing though. Whenever an element has up to 5 electrons in its atomic shell, it will have to borrow more 3 to complete. Therefore, the valency of that element is 3. If the element has 6 electrons in its atomic shell, it will have to borrow 2 to complete its octet stability. That means the valency of that element is 2. If an element has 7 electrons in its atomic shell, it will have to borrow more 1. Therefore, the valency of the element is 1. But if an element has 1 electron in its atomic shell, it will not borrow 7 electrons. It will be hard for it to borrow 7 electrons more. Therefore, it will have to lose this 1 electron. Therefore, its valency is now 1. If an electron has 2 electrons in its atomic shell, it will be hard to borrow 6 more electrons to complete octet than losing the 2. So it will take the more easiest one. It will have to lose these 2 electrons. Therefore, the valency of the element is 2. If an element also have 3 electrons in its atomic shell, it will have to lose those 3 other than borrowing 5. Therefore, the valency of the element will be 3. If an element also has 4 electrons in its atomic shell, it will have to lose the 4 or gain the 4, because the ability of losing the 4 and gaining the 4 are somehow equal. So it will have to gain or lose 4 electrons. So the number of electrons it will gain or lose here, this means its valency to be 4. Let's go back to our day. Let's say we are looking for the oxidation state of carbon here. Meanwhile, we say that the overall oxidation state of a neutral compound is equal to 0. We first look for oxidation state of calcium. Oxidation state of calcium here is +2. And why is it +2? The valency of calcium is 2, as we all know how to find valency. Then it is now plus because calcium has 2 electrons in its atomic shell, so it will have to lose those 2 electrons other than borrowing 6. So when an element is losing, its oxidation state will be positive, but when an element is gaining electron, its oxidation state will be negative. Why? when an element is gaining electrons, we know that electrons have negative charges. So when an element is gaining electrons, it will acquire more negative charge, more than the positive charge inside the nucleus, which are the protons. So it will have more electrons than protons, thereby negative charges overshadowing positive charges. That's why if an element is gaining more electrons, it will become negative. But if an element is losing more electrons, the positive charges contained by the element will overshadow the negative charges, thereby having an outcome of a net positive charge. That's why calcium has positive charge here, plus that of carbon, which we are looking for. And oxygen, the oxidation state of oxygen is -2 times 3, which is equals to 0, plus 2 plus C minus 6 is equals to 0. So C is equals to 6 minus 2. This is equals to plus 4. That's the oxidation state of carbon in this compound. Let's look at copper 2 tetraoxo sulfate 6. We said sulfate 6 due to the oxidation state of sulfur in copper 2 tetraoxo sulfate 6 is 6. So let's look at oxidation state of sulfur from this compound. Oxidation state of copper is +2 and plus that of sulfur, which we are looking for, plus the oxidation state of oxygen is -2, and there are 4 here, that is times 4 is equals to 0. Remember we said that oxidation state of a neutral compound is 0, that is why we equated to 0 here. Then we have +2 plus S minus 8 is equals to 0. Then S is equals to 8 minus 2, which is equals to plus 6. When we want to name this compound, we said copper tetraoxo sulfate 6. That is this 6 here. That's it. Let's move over to balancing of chemical equation. Okay, let's first represent a reaction. Sodium hydroxide reacting with tetraoxo sulfate 6 acid. From here, this will combine with this, and this will combine with this to form sodium tetraoxo sulfate 6 plus water. We would like to balance this equation. First of all, we check for sodium. Here sodium is 1, but here there are 2 atoms of sodium. Sodium is not balanced. We balance sodium by adding 2 here. Meanwhile, let's also know that whenever we add a number in front of a compound, like here, it will affect every element in this compound. Sodium is now 2 here, and sodium is also 2 here, so sodium is balanced. Then let's check for oxygen. Oxygen now is 2 here because this 2 is also affecting oxygen. So oxygen is 2 here plus this 4, that making it 6 in the reactant side. Then on the product side, oxygen is 4 here and 1 here, that is making it 5. So we need 1 more oxygen to complete. So if we add 2 here, then these 2 will be affecting both hydrogen and oxygen. Also note that when we want to balance a compound, we don't add numbers to the elements particularly. For example, we don't add number here or something like that. No, we don't do that. Or if we want to add, we come here, add something like this. No, there's nothing like that. We add a number in front of the compound, which affects the whole element in the compound. So putting it here, we have 4 oxygen here plus 2. That is, this 2 is affecting this oxygen, making it 6 oxygen here. So oxygen is now balanced. Then hydrogen, we have 2 hydrogen here plus these 2, making it 4. Then here we have 2 times 2, that is 4 hydrogen. Hydrogen is balanced. Then sulfur, we have 1 sulfur here, and we also have 1 sulfur here. That is, everything is now balanced. So this is a balanced chemical equation of reaction between sodium hydroxide and tetraoxosulfate 6 acid. Let's look at one more example. Let's look at hydrochloric acid plus calcium hydroxide to form, like I told you, this goes with this and this goes with this, to form calcium chloride plus H2O. Okay, let's balance this. Let's start from hydrogen first. Here there is 1 hydrogen here, and here these 2 will be affecting all the numbers in this bracket apart from this calcium. That's another difference. So there is 1 hydrogen here and 2 hydrogen here, but here there is only 2 hydrogen in the product side. So we need 1 more hydrogen, adding it up to 3 to complete. If we add 1 here, it will still be 1 times 2, that is 2 hydrogen total. So let's add 2 here. If we add 2 here, now we have 4 hydrogen here, and here we have 3 hydrogen. So we need to add 1 more hydrogen. If we add 1 here, it will still be 1 hydrogen. So we add 2 here, that is making it 2 hydrogen here, 2 hydrogen here, that is 4, and also 4 hydrogen here, that is, hydrogen is now balanced. So here we have 2 chlorine and 2 chlorine here also. Here we have 1 calcium and 1 calcium here also. Then for oxygen, we have 2 oxygen and also 2 oxygen here. It's now balanced. So this is a balanced chemical equation of HCl reacting with calcium hydroxide. Thank you.